Hello. Today's webinar is about using the multi-cohort tool for evaluations of post-secondary education interventions. The multi-cohort tool is designed to support the development of a plan for the evaluation of a post-secondary education intervention. It can be used to identify all of the potential student samples from multiple cohorts and time points that may be included in analyses of intervention impacts. The tool also supports decision-making about the study samples to be included in analyses based on the focus of the evaluation's research questions. Today's presentation was prepared by members of the First in the World Evaluation Technical Assistance Team, Ann Wolf and Christopher Price. I'm Ann Wolf, and I'll be doing the presentation today. At the end of the webinar, you will understand the large array of potential student samples in multi-cohort evaluations. Specifically, samples may group students on a number of dimensions, such as amount of exposure, grade level, and time relative to the start of the intervention. And you'll learn how to use the multi-cohort tool to generate all of the possible samples for your evaluation and identify the samples that will address the evaluation research questions. You can access the tool online on the First in the World Evaluation Technical Assistance website or the IES Evaluation Technical Assistance website. Many education interventions span more than one semester or year, are implemented with students at multiple grade levels, are implemented with multiple cohorts of students, and often collect data at multiple points in time. This creates an array of options for organizing the sample, depending on the research questions that the evaluation aims to address. The multi-cohort tool helps identify these options, creating the opportunity for evaluators questions about a program's effects for students to examine impacts on students with different amounts of exposure, for example, 1 semester of exposure, 1 year of exposure to the intervention, to examine programs' effects for students at different grade levels, for example, freshmen or sophomores, or even by semesters for students in their first semester of college or second semester of college, and to examine programs' effects for students at different points in time relative to the start of the intervention. So in semester 1 or semester 2, or so on. As you'll see in the remainder of this presentation, the tool can be used to identify all the potential samples of students across multiple cohorts and time points. And the tool also supports decision-making about which study samples to include in the analysis, and how to group those samples based on the focus of the evaluation's research questions. On the next slide, we provide an example of how many samples can be generated from an apparently simple evaluation design. For example, consider a 2-semester intervention for freshmen and sophomores, which is implemented with 3 cohorts of students over 3 years. Data from this evaluation could be used to form at least 24 different samples to examine program impacts by exposure level for up to 2 semesters of exposure, grade level for up to 2 grade levels, and time up to 6 semesters since the start of the intervention. With all the potential analyses that can be conducted, it's important to determine what research questions are of highest priority. Then, in planning the evaluation, you can be guided by those research questions in order to narrow the focus and reduce the number of impacts that will be estimated. There are a couple of reasons why you might want to reduce the number of impacts that you will estimate. First, it makes sense to present a more focused examination of the intervention's impacts on the primary outcomes, rather than to present many different estimates that may provide inconsistent information about program effects. And second, conducting many tests of the intervention's impacts increases the probability of finding a statistically significant effect when it does not exist. This is called type 1 error. In order to reduce this risk, the What Works Clearinghouse adjusts for multiple comparisons by setting a more stringent threshold for statistical significance based on the number of tests being conducted. Therefore, instead of estimating all the possible intervention impacts, you want to focus on a well-considered set of tests that will provide evidence about the intervention's effectiveness. And finally, you can be guided by the research questions, your primary research questions, to identify the corresponding samples that should be included in the impact analysis to address those questions. The multi-cohort tool for post-secondary education interventions is an interactive Excel-based tool. It's intended to help evaluators make decisions about who to include in impact analyses. It is used for interventions and evaluations with multiple cohorts, multiple grade levels, and that span multiple semesters or years. When deciding about the groups of students to be included in the evaluation samples, it's helpful to begin by identifying all the possible groups of students that will experience the intervention and comparison conditions. The multi-cohort tool generates a diagram showing all of these possible groups of students based on answers to a set of questions about the timing and duration of the intervention, about the evaluation design, the students participating in the study, and the timing of data collection. Once the diagram is generated by the multi-cohort tool, the user identifies the groups of students to be included in the evaluation sample in order to address key research questions. Here we see the cover page of the tool. When you open the tool, you can see that the Excel spreadsheet has 4 tabs. The 4 tabs are the README First tab, the Design Questions tab, the Matrix tab, and the Matrix Explainer tab. Using the multi-cohort tool to identify your study's samples involves 5 steps. Step 1 is to select the correct version of the tool. There are different versions of the tool to reflect the education level of the intervention and the evaluation design. Therefore, the first step is to select the appropriate version of the multi-cohort tool. There's a general version for most designs and a cluster RCT version. Step 2, answer a set of 9 questions about the evaluation design. Your responses will guide the production of the sample diagram or matrix. Step 3 is to review the automatically generated matrix. Based on your answers to the design questions, a diagram showing all the groups of students that can potentially be included in the sample will be generated. You can review it, and you can return to the Design Questions tab to make any corrections if necessary. Step 4 is to consult the Matrix Explainer tab to be sure that you understand the layout of the sample matrix. A general explanation of the format of the sample diagram is provided on the Matrix Explainer tab. And step 5, after the matrix has been generated, you can identify the groups of students that will be included in the sample for each of the impacts that will be estimated. Samples may be combined to measure outcomes for students with the same amount of exposure to the intervention, for example, 2 semesters, in the same grade level at the end of freshman year, or at the same point relative to the start of the intervention, for example, semester 4. We'll begin with step 1, selecting the correct version of the tool. There are different versions of the multi-cohort tool depending on the education level of the student served, post-secondary education or K-12 education. The tools are built differently to reflect differences in grade levels and in the academic calendar, so focusing on semesters for post-secondary education or school years for K-12. We're focusing on the post-secondary tool today only. A K-12 multi-cohort tool is forthcoming. It's not yet available. For each education level, post-secondary or K-12, there are 2 versions of the tool based on the evaluation design. There's a general version, which is appropriate for all designs other than cluster RCTs. So it's used for student level assignment RCTs, for QEDs with assignment at the student or cluster level, or for regression discontinuity designs. And then there's also another version for cluster RCTs. Overall, the two versions are very similar, but there's one key difference in the layout of the diagrams produced by each version. The key difference is that for cluster RCTs, the diagram includes information about students' status as joiners or stayers. Because clusters of students, such as classes, instructors, or schools, are assigned to either the treatment or comparison condition, some students may join those clusters after initial group assignment. These students are called joiners, while other students are already present in the clusters before initial group assignment, and these students are called stayers. In cluster RCTs, students joining clusters after random assignment can bias the estimate of the intervention effect if those who enter intervention clusters differ systematically from those who enter comparison clusters. This distinction between stayers and joiners is not relevant or applicable for other designs other than cluster RCTs. Therefore, the distinction does not appear on the general version of the tool, only on the cluster RCT version of the tool. And finally, the potential for bias from entering individuals may be affected by how long after random assignment students join clusters. Namely, bias may differ for students who join soon after the study begins. These students are called early joiners, or for students who join clusters at a later time point. These students are called late joiners. For more information about the WWC standards for cluster RCT designs, excuse me, you can see the WWC Standards Handbook version 4.0 on the WWC website. Okay, now we'll go over each of the tabs on the multi-cohort tool, beginning with the README First tab. On the README First tab, you can confirm that you're using the appropriate version of the multi-cohort tool by answering two questions about the education level of the intervention, post-secondary or K-12, and about the evaluation design, cluster RCT, or another design. So you'll begin by answering question 1. You need to indicate the target population of the intervention. And from a drop-down menu, you can select either K-12 or post-secondary. Then for question 2, you need to indicate the evaluation design. From the drop-down menu, you can select your evaluation design from among the following options: RCT assignment at the student level, RCT assignment at the cluster level, QED assignment at either the student or cluster level, or regression discontinuity design. Based on your responses, the tool will indicate whether or not you're using the correct version. So here's an example where the user has the general version of the tool, the general version of the post-secondary tool, and has responded to question 1 that he or she is using the post-secondary, is evaluating a post-secondary intervention, and then has indicated the design as a cluster RCT. Therefore, the tool has responded to these questions, indicating that the user is not using the correct version. And then when this statement appears indicating that you are not using the correct version, you'll be directed to the correct version of the tool for the education level and evaluation design that you've indicated. So in this case, the message back to the user says, please use the version for post-secondary cluster RCTs. When you're using the right version of the tool, you will receive a message in a green box stating that you are using the correct version. So in this example, the user has indicated that they are evaluating a post-secondary intervention using a QED design. And because they are answering these questions in the general version of the post-secondary multi-cohort tool, they have gotten a message back saying this is the correct version. Next is step 2. Answer questions about the evaluation design on the Design Questions tab. On the Design Questions tab, there are 9 questions about the evaluation design. The same 9 questions are asked on both versions of the multi-cohort tool. For each question, the answer is entered into the orange box, either by typing the response directly or by selecting a response from the drop-down menu. Once the questions are answered, a diagram or matrix will be generated automatically on the Matrix tab, which will show all the possible groups of students that may be included in the sample. To orient you to the Design Questions tab, I'm showing you what the tab looks like here and showing questions 1 to 5. We'll go over the questions on a later slide and complete them for an example design. And here, this is what questions 6 through 9 look like on the Design Questions tab. We can use an example design scenario to complete the questions. So let's say we're evaluating a new first-year seminar for incoming freshmen, which is intended to improve students' persistence and credit accumulation. The evaluation will include 2 cohorts of incoming freshmen who participate in the intervention or comparison condition. We'll collect outcome data on persistence and credit accumulation after each semester of exposure and for 2 semesters post-intervention, for a total of 4 semesters of data collection for each cohort. And the evaluation will collect baseline data prior to college, for example, collecting SAT scores and Pell Grant eligibility. This same example can be used for either version of the tool. The questions and the answers are the same, even though the matrix that's generated differs for the 2 versions. So here are questions 1 to 5 on the Design Questions tab, and we can answer them for our example. So the first question asks, in which academic year will your intervention, program, practice, or policy begin? We begin by entering 2015 for our example. You can just type that into the cell, and then from this point forward, all the other questions are completed using a drop-down menu. I won't be illustrating how the drop-down menu is used in the presentation, but you can experiment with the tool on your own, and you can also provide different responses to questions and examine the differences in the matrices that are generated. Next, you indicate in which semester your intervention will begin, either fall or spring. In this case, we're entering fall 2015 as the beginning of the intervention. The next question asks how many separate cohorts of students are in your study, and in our example, there are 2. Then, how long in semesters will data be collected during the intervention? In this example, data will be collected for 4 semesters for each of the 2 cohorts, which is a total of 5 semesters of data collection, because the second cohort begins 1 semester later than the first, adding an extra semester of data collection on to the total. Next, we answer the question, what is the earliest grade level a student could begin participating in or receiving the intervention? And the answer to that in our example is their first semester in college, because it's a first-year seminar for students in their first and second semesters, and they begin in their first semester. Then the next question asks, what is the latest grade level that students could begin participating in or receiving the intervention? And in our example, again, the answer to that question is the first semester in college. But there, you can imagine other interventions that may serve students in multiple grade levels, beginning at different times, different grades. Okay. Next, we proceed through questions 6 through 9. And for question 6, there are 3 different parts. The first part asks, is baseline measured at the same grade level for all students? So in our example, we answer yes, the grade level, and we indicate the grade level in response to question 6b. which says if you answered yes for 6A, what grade level is baseline measured for all students? In our example, that's pre-college. If we had answered no to question 6A and said that baseline is not measured at the same grade level for all students, then question 6B would have disappeared, and we would respond to question 6C, which would have asked what is the grade level when baseline is measured, and we would have selected from a drop-down menu options such as the start of the first semester of the intervention or 1 semester before the intervention, and the like. But because we've answered yes, then question 6C has disappeared from our options. Next, we go on to question 7, which asks, what is the maximum number of semesters that students can participate in the intervention or comparison condition, which is 2 semesters in our example. Question 8 asks, what is the highest grade level during which students can participate in the intervention or comparison condition, which is their 2nd semester in college in our example. We have a 2-semester, 1-year intervention for students that they participate in during their 1st semester in college and their 2nd semester in college. And then the last question asks, how many semesters post-intervention will you collect data? And in our example, as we've stated, that's 2 semesters post-intervention. Okay, next we can review the automatically generated matrix. On the Matrix tab, once all the design questions have been answered, the Matrix tab will provide a customized diagram that shows all the groups of students that can potentially be included in the sample for impact analyses. We're going to look at the 2 versions of the matrices produced from our example, one at a time. First, we'll look at the matrix produced by the general version of the tool, and then we'll look at the matrix produced by the cluster RCT version. So this is the matrix produced from the general version of the tool. The layout of the rows is the same in both versions of the matrix. The top row, which is shaded beige, provides a letter to label each of the columns that have information about students in the sample. This enables the user to refer to specific cells by naming the column letter and the row number. For example, cell A1 or cell A2. Then there's the cohort row, which provides the cohort number. Each cohort is shaded a different color. The shaded color may vary depending on the number of cohorts in your evaluation. In this example, cohort 1 is shaded blue and cohort 2 is shaded purple. Next is the baseline row, which provides information about when the baseline variable is measured for students shown in the same column. The baseline cells are shaded orange, and in our example, baseline is measured before college, so the cells say pre-college for each column and each cohort. Okay, next are the numbered rows, and these rows correspond to the progression of time in semesters relative to the start of the intervention. Each row represents a semester, beginning with the first semester that the intervention is implemented, during which data will be collected. In this example, as well as in the cluster RCT example that we'll be looking at, there are 5 rows. Row 1 is semester 1, which is the fall semester of the 2015-2016 school year in our example. Row 2 is semester 2, the spring semester of the same academic year, spring 2016. Row 3 is semester 3, row 4 is semester 4, and row 5 is semester 5. So fall 16, spring 17, and fall 2017. In the general version of the matrix, the columns correspond to each grade level within a cohort. In this example, there are 2 cohorts there are 2 cohorts, each with students from 1 grade level, first semester freshmen. Therefore, there are a total of 2 lettered columns. Column A shows the progression of incoming freshmen in cohort 1 from their first semester in college through their 4th. And column B shows the progression of incoming freshmen in cohort 2. The cells in the columns include information about two aspects of time. Grade level. The cells show students' grade level in college in semesters as students move through from their first semester to their second semester to their third semester through their fourth semester in college. And the cells also include information about the amount of exposure, the number of semesters of exposure to the intervention, which depends on the duration of the intervention. So one semester of exposure to the intervention or comparison condition is shaded red and occurs in fall 2015 for cohort 1 in our example, and spring 2016 for cohort 2 in our example. 2 semesters of exposure is shaded green. And then in addition to information about the amount of exposure, cells may also include information about the number of semesters since the end of the intervention if data collection continues past the end of the intervention. So in the example, data are collected 1 semester post-intervention, which is written as 1S post, referring to 1 semester post-intervention, and 2 semesters post-intervention is written as 2S post. And note that as described above, the third aspect of time captured by the matrix, in addition to grade level and amount of exposure or post-intervention follow-up, is the time relative to the start of the intervention, which, as we mentioned before, is represented by the rows in the diagram. Okay, now here is the matrix produced by the cluster RCT version of the tool, assuming that we answered the 9 questions in the design question tabs in just the same way that we did for the general version of the tool. Okay, and again, remember the example is an intervention that begins in fall of the 2015-2016 school year with data collected for a total of 5 semesters from 2 cohorts of first semester students who participate in a 2-semester intervention with outcomes collected for 2 semesters post-intervention. In the cluster RCT version of the matrix, the layout of the rows is the same as in the general version. The top row is shaded beige and provides a letter to label the columns. The second row provides the cohort number. The third row provides information about when baseline is measured for students shown in the same column. The next set of rows corresponds to the progression of time relative to the start of the intervention, with each row representing a semester. Again, there are 5 rows, 1 for each semester of data collection across the 2 cohorts. In the matrix for cluster RCTs, just as in the general version of the tool, the lettered columns also correspond to each grade level within a cohort of students. However, for each grade level, in the first cohort of students, the columns are divided into 3 parts, distinguishing student status as stayers, early joiners, or late joiners. In this example, there are 2 cohorts of students, each with students from 1 grade level, first semester freshmen. The first cohort of students, instead of having 1 column of students in their first semester in college, there are 3 columns. Column A shows the progression of incoming freshmen in cohort 1 who joined the cluster well after random assignment. These are the late joiners. Column B shows the progression of incoming freshmen in cohort 1 who joined the cluster soon after random assignment. These are the early joiners. And column C shows the progression of incoming freshmen in cohort 1 who were present in clusters at the time of random assignment and are labeled stayers. All subsequent cohorts of students are late joiners because the students enter the clusters well after random assignment, at least 1 semester later. In this example, the second cohort of first semester freshmen appears in column D, and the cell number D2 is labeled late joiners. Apart from distinguishing student status as stayers, early joiners, or late joiners, the layout of the cluster RCT matrix is the same as the general version of the tool. In the cluster RCT version, the cells in each column include the same information previously described for the general version about grade level and about amount of exposure to the intervention or post-intervention follow-up. Next is step 4, to consult the Matrix Explainer tab. You want to do that to be sure you understand the layout of the sample matrix. The Matrix Explainer tab provides illustrations and definitions for each part of the diagram produced in the Matrix tab. For orientation, we show what the Matrix Explainer tab looks like on the general version of the Multi-Cohort tool. There are explanations for 3 aspects of the diagram that are provided as a reference for the user. The first 2 statements and illustrations focus on the baseline row and the cohort row, and those are the same in both versions of the tool. But the third statement and illustration, which is about the remaining rows showing the progression of time, that differs on the 2 versions. So we're going to look at both the third statement for both versions, and they'll be described in this section. So on the next set of slides, we'll look more closely at each of these 3 statements and illustrations. The first statement shown on the Matrix Explainer tab, again, is the same for both versions of the tool. It describes and illustrates the cohorts row in the matrix. For each cohort, cells are shaded a different color. In the examples shown on the Matrix Explainer tab, there are 3 cohorts labeled 1 for cohort 1 and shaded blue, 2 for cohort 2 and shaded white, and 3 for cohort 3, shaded purple. Note that there are 4 columns for each cohort, and as described previously, each column corresponds to a grade level within a cohort. Therefore, 4 columns per cohort occur when there are 4 grade levels in each cohort. The cohort row does not provide information about grade level. Grade level information appears on a later row in the matrix and is described in the third illustration on the Matrix Explainer tab. The second statement shown on the Matrix Explainer tab is also the same in both versions of the tool. It describes and illustrates the baseline row of the matrix. In the matrix, baseline cells are all shaded orange, and the values are the grade level when baseline is measured. In the examples shown, baseline is measured at the beginning of the first treatment or comparison semester. Therefore, the grade level differs for each column, depending on students' grade level at entry into the study. Their first semester in college, second semester in college, third or fourth semester in college. In the general version of the tool, the third statement on the Matrix Explainer tab describes and illustrates the remaining rows of the matrix. Here, I'm only able to show the first sentence that appears on the tab, just to keep the text on the slide, on the screen, a readable size, but I will go over all the information about the rows that's covered on the Matrix Explainer tab. So all subsequent rows have a heading to indicate the school year and the semester, fall or spring, that's represented by the row. And as described previously, cells in these rows provide information about students' grade level and amount of exposure to the condition or the post-intervention follow-up. Okay, grade level is, which is semesters in college, is written as text without any shading. For example, first semester in college is written as first semester, second semester, third semester, and so on. Semesters of exposure to the intervention or comparison condition are shown as shaded cells. In this example, 1 semester of exposure is written as 1 and shaded red. 2 semesters of exposure, written as 2, is shaded yellow. And 3 semesters of exposure, written as 3, is shaded green. If data collection continues past the end of the intervention, the number of post-intervention semesters is indicated. 1 semester post-intervention is written as 1S post without shading. In the cluster RCT version of the tool, the third statement shown on the Matrix Explainer tab also describes and illustrates the remaining rows of the matrix. Again, all the text that appears on the Matrix Explainer tab is not shown here for space reasons, but I'll go over all the information. The rows follow the same structure as the general version, with row headings that indicate the school year and semester follow spring. And cells in these rows provide information about grade level and amount of intervention exposure or post-intervention follow-up. The difference between the cluster RCT and the general version is that the cells in the cluster RCT version of the tool also distinguish students as stayers, early joiners, or late joiners, based on when they joined the cluster relative to the timing of random assignment. Okay. Once the sample diagram or matrix is generated, the next step is to identify the specific groups of students from each relevant cell in the matrix that will be included in the evaluation sample used to address each research question for each impact that will be estimated. So impacts could be estimated for students with the same amount of exposure to the intervention or comparison condition, regardless of their grade level or the point in time relative to the start of the intervention. Or impacts could be estimated for students at the same grade level, regardless of the amount of exposure to the intervention or time relative to the start of the intervention. Or impacts could be estimated for students at the same point in time relative to the start of the intervention, regardless of their amount of exposure to the intervention or their grade level. In order to identify the cells in the matrix that will be included in the evaluation sample, you can create a version of the matrix that can be copied or edited. To do this, you click the button on the Matrix tab that says Generate Editable Version of the Matrix, and a new spreadsheet will be created with a copy of the matrix. The new version of the matrix can be edited, and it can be copied and pasted into other documents, such as an evaluation plan. And then you can highlight the cells in the matrix representing the students to be included in the impact analyses for each research question, or you can simply reference the relevant cell numbers using the column letters and row numbers. I want to point out that the multi-cohort tool for post-secondary interventions generates diagrams in which academic terms are represented as semesters. For post-secondary interventions that involve quarters or trimesters or other terms, it will be necessary for you to modify the matrix to accurately reflect the actual academic terms in your evaluation. Okay. We're going to go over examples for how to use the matrix to identify the student sample for 3 different research questions focused on amount of exposure, grade level, or time point relative to the intervention. So for amount of exposure, we can consider the research question, what is the impact of the intervention on persistence and credit accumulation for students after 1 semester of the intervention, 1 semester of exposure? For grade level, we might focus on a research question like, what is the impact of the intervention on students at the end of their sophomore year or their 4th semester in college? And for time since the start of the intervention, we could consider the research question, what is the impact of the intervention on students after the intervention has been in colleges for 3 years at the end of semester 6? These examples are presented for both versions of the matrix. First, we're going to go through these 3 examples for the general version, and then we'll go through the same 3 examples for the cluster RCT version. Before we go through the examples of how to identify the samples based on the research questions, I'll introduce the matrix showing all the potential samples, which will be the basis of our example research questions. So this is a matrix generated by the general version of the multi-cohort tool. The matrix would be produced for for a student RCT, a QED, or a regression discontinuity design, but not a cluster RCT. For a cluster RCT, you would use the other version of the tool. And we, as I mentioned, will look at examples using the cluster RCT after we look at examples using the general version. In this matrix, there are 3 cohorts of students who participate in the intervention or comparison condition. For up to 2 semesters in their first and second semester in college, or who participate in the business as usual condition during that time. Outcomes will be measured each semester from fall 2015 through spring 2016. We begin with example 1. What is the impact of the intervention on persistence and credit accumulation for students after 1 semester of exposure to the intervention? For this research question, the student sample would be comprised of students in cells representing 1 semester of exposure, regardless of their grade level and regardless of the program semester, the time since the start of the intervention. In the example matrix, outcomes are measured for students in 6 cells, shown here outlined in red. These students have the same amount of exposure to the intervention. All students will have had 1 semester of exposure to their assigned condition when outcomes are measured. The students in the sample will be different grade levels when outcomes are measured. Some will be in their first semester in college, and others will be in their second semester in college. And students will have outcomes measured at different times relative to the start of the intervention. Some students will have outcomes measured in semester 1, fall 2015 in this example, some in semester 2, and some in semester 3. Similarly, samples could be identified to examine outcomes for students with 2 semesters of exposure, which would be are shown here, shaded green, and data would come from these 3 cells, 3 groups of students. Or outcomes could be measured for students at 2 semesters post-intervention. In these examples, students are the same grade level, but outcomes are measured at different time points relative to the start of the intervention. Next, we'll look at example 2. What is the impact of the intervention on students at the end of their sophomore year, their 4th semester in college? For this research question, the student sample would be comprised of all the cells in the matrix in which students are sophomores, regardless of their amount of exposure or the amount of time since the start of the intervention. In this example, the sample would include students in the 6 cells that are outlined in red. Students in the sample would all be the same grade level. They would all be in their 4th semester in college. The students in the sample would have different amounts of exposure to the intervention. Some students will have 1 semester of exposure, and others will have 2 semesters of exposure. And students in the sample will have outcomes measured at different times relative to the start of the intervention. For some students, outcomes will be measured in semester 3, for some in semester 4, for some in semester 5, and for some in semester 6. Similarly, samples could be identified to examine outcomes for students at the end of their junior year, the end of their 6th semester in college, as shown here. Next is example 3, with the research question, what is the impact of the intervention on students after the intervention has been in colleges for 3 years, at the end of semester 6? For this research question, the student sample would be comprised of all cells in the matrix corresponding to semester 6, regardless of students' amount of exposure to the intervention or their grade level. In the example matrix, the sample would include students in 5 cells, shown here outlined in red. Outcomes would be measured at the same time relative to the start of the intervention. All students in the sample in semester 6 will have outcomes measured. Students in the sample would have different amounts of exposure to the intervention. Some students will have 1 semester of exposure and others will have 2 semesters of exposure. And outcomes will be measured at different post-intervention follow-up time points. Some students will have outcomes measured 4 semesters post-intervention, some 3 semesters post-intervention, and some at 2 semesters post-intervention. And students in the sample would be at different grade levels. Some students would be in their sixth semester in college, some in their 5th semester, and some in their 4th semester in college. Okay, now we can go through these same examples again, but this time using the cluster RCT version of the tool. So again, we can look at 3 different research questions. One focused on impacts after 1 semester of exposure, one focused on impacts on students at the end of their sophomore year, the end of their 4th semester in college, and one focused on impacts of the intervention after it has been in colleges for 3 years at the end of semester 6. But before we go through the examples for the cluster RCT version, I want to introduce the matrix generated by the cluster RCT version of the tool, which forms the basis for our example research questions. So it's the same intervention and design as we described for the general version, but the matrix looks different. In this cluster RCT, there's 1 cohort of schools that's randomly assigned to the treatment or comparison condition. And within those schools, there are 3 cohorts of students who participate in the intervention for up to 2 semesters in college, or who participate in the business as usual comparison condition during that time. And outcomes will be measured for each semester from fall 2015 through spring 2018. With a cluster RCT design, again, it's necessary to specify whether the sample will include students who were present in clusters at the time of random assignment, stayers, or whether the sample will also include students who joined clusters soon after random assignment. In other words, whether the sample will include stayers and early joiners, or whether the sample will include any students who are in clusters at the time that outcomes are measured. In other words, that the sample will include stayers, early joiners, and late joiners. So returning to example 1 for the cluster RCT design, we look at the samples that would be used to address the research question of what is the impact of the intervention on persistence and credit accumulation for students after 1 semester of exposure to the intervention. For this question, for the cluster RCT, again, we need to determine whether the sample will include joiners or not. If we were to focus on the sample of students that have 1 semester of exposure, regardless of grade level, or semester since the start of the intervention, and focus on students who were present in schools at the time of random assignment, a sample with only stayers, then outcomes would be measured for students in 2 cells, shown here outlined in red. Specifically, students in the sample would have the same amount of exposure to the intervention. All students would have had 1 semester of exposure, and all students would be stayers, students who were present in schools or whatever the clusters are at the time of random assignment. Outcomes would be measured at the same time relative to the start of the intervention. For all students, outcomes would be measured in semester 1, and but for students at different grade levels. The sample would include some students in their 1st semester in college and others in their 2nd semester. Similarly, samples could be identified to include early and late joiners as well as stayers when examining outcomes for students with 1 semester of exposure. So you could expand to include joiners, and many more groups of students would be included, including those from cohorts 2 and 3. Or if you wanted to examine impacts on students with 2 semesters of exposure and also includes stayers, early joiners, and late joiners, then the sample would include students in 5 cells, the 5 cells with a green bar showing 2 semesters of exposure. And these cells are shown outlined in pink. Next, we'll look at example 2, the question about impacts on students at the end of their sophomore year, or at the end of their 4th semester in college. The sample will include students at the end of their sophomore year, 4th semester in college, regardless of their amount of exposure to the intervention or the time since the start of the intervention. And then if the impact analysis focuses on sophomores who were present in schools at the time of random assignment and soon after, in other words, both stayers and early joiners, then outcomes would be measured for students shown in 4 cells, those cells that are outlined in red. Specifically, students in the sample would be the same grade level. All students would have completed their 4th semester in college. The sample would include students present in schools at the time of random assignment or soon after, stayers and early joiners. Students would have had, in the sample, would have had different amounts of exposure to the intervention, some with 1 semester of exposure and others with 2 semesters of exposure. For all students, outcomes will be measured 2 semesters post-intervention. And outcomes will be measured at different times relative to the start of the intervention. For some students, outcomes will be measured in semester 3, and for other students in semester 4. Similarly, samples could be identified to examine outcomes for students at the end of their junior year, their 6th semester in college, including stayers and early joiners, which are shown here outlined in pink. Last is example 3 for the cluster RCT design, addressing the research question, what is the impact of the intervention on students after the intervention has been in colleges for 3 years, at the end, measuring outcomes at the end of semester 6. For the cluster RCT design, again, we need to just specify whether the sample will include stayers, early joiners, and or late joiners. If the impact analysis focuses on all students in semester 6, regardless of the amount of exposure or grade level, and regardless of when they entered schools, in other words, a sample that includes stayers, early joiners, and late joiners, then outcomes would be measured for students in 5 cells, shown here outlined in red. Specifically, outcomes would be measured for students at the same time relative to the start of the intervention. Outcomes would be measured at the end of semester 6. Students in the sample would include those who were present in schools all students who were present in schools at the end of semester 6, regardless of when they entered the schools, whether they were stayers, early joiners, or late joiners. Outcomes would be measured for students at different grade levels. Some students in the sample would have completed their 4th semester in college. Others would be in their 5th semester in college, and others would be in their 6th semester in college. Outcomes would be measured at different time points post-intervention. Outcomes would be measured 2 semesters post-intervention for some students, 3 semesters post-intervention for some students, and 4 semesters post-intervention for some students. All students would have had 2 semesters of exposure to the intervention. Okay, and that's all these 3 examples for both versions of the tool. So from this webinar, you should know how to select the correct version of the multi-cohort tool for post-secondary education interventions for your evaluation. You should be able to use it to generate a customized matrix for your evaluation design that allows you to identify the samples to include in your impact analysis based on the focus of the evaluation research questions. You may find it helpful to revisit the tool and your customized matrix over the course of the evaluation. especially if changes occur in the intervention or your evaluation plans. I want to point you to some additional resources for the multi-cohort tool. There's, of course, the multi-cohort tool for post-secondary interventions itself, the tool itself, both the general version and the cluster RCT version. And there's also a user's guide, and all of these things are available online on the First in the World Evaluation Technical Assistance website or the IES Evaluation Technical Assistance website. And finally, if you're conducting an evaluation that's focused on an intervention serving students in kindergarten through grade 12, there is an analogous tool, K-12 multi-cohort tool, and user guide, which are forthcoming. They're not available yet. And finally, the recording of this webinar is also available online on the First in the World Evaluation Technical Assistance website and the IES Evaluation Technical Assistance website. Thank you.